Hello students. So students, in the previous class we have started with a new chapter, and that is metals and non-metals. If we talk about the metals and non-metals, students, we have seen that metals and non-metals, basically both of them came from the term element. Now, element is what, student? Element is what, a student? Element is a pure substance that we obtain from our surrounding, from our earth crust. And these elements are basically divided into two, that is metals and non-metals. If we talk about that of the metal and non-metal, metals are what, student? These are generally hard, they are generally strong, as well as they are a very good conductor of heat and electricity. If we talk about that of the non-metal, so they are generally soft. They are generally, metals, they are basically bad conductor of heat and electricity, students. So we understand the metals and that of the non-metal with the help of its properties. So what is the first property on the basis of which? What is the first property on the basis of which we can distinguish between that of the metals and non-metals? So the first property is, student, is the state. So the first property is, a student, is its physical state, and in the physical state we used to see that the metals, students, basically they are solid. Most of the metals are solid in nature except that of the mercury. So mercury is what? It is always liquid in a state. What about the non-metal, students? So non-metals, they are generally solid. They can be liquid or they can be gases also. If we talk about solid, so sulfur and phosphorus are the solid one. If we talk about the liquid, so bromine. Gaseous, hydrogen, oxygen, nitrogen, helium, these all are what? These are the gases which we include into that of the non-metal. Second one is luster, means shining in appearance. So metals, they are generally lustrous, means they used to shine. So if you look all the metals, they are lustrous. It means they are having shiny appearance. When you look at them, they used to shine. Non-metal, they are non-lustrous. It means they are dull. Here, student, again an exception is there, and that is diamond, graphite. These all are what? These all are the non-metals, but they used to shine, used to show the luster. Next one is malleability and ductility. Malleability is what? In which metals can be drawn into thin sheets by beating them. Ductility in which metals can be drawn into thin wires. So in both the cases, we have seen that metals are malleable, metals are ductile. It means it shows the properties of both malleability and ductility. What about non-metal? They are non-malleable and non-ductile. Instead of that, they show the property called brittleness. So non-metals, they are generally brittle. It means they used to show the property of a brittleness. What is the meaning of a brittle, student? It means if we beat an object with the help of hammer, then instead of drawing it into thin sheets, instead of drawing it into thin wires, it will break down into pieces. This is what? This is the ductility and malleability. Moving on, and we will see some other physical properties of metal and non-metal. So, hardness. Hardness. So, basically, if we compare that of the metals with that of the non-metals, we will find that metals are generally hard and non-metals, they are quite soft. So, we can write it here that most metals are generally hard except potassium and sodium. Yes, students, potassium and sodium are soft metal. So we can write it here. Potassium and sodium. You see that these are very soft. It means these are this much soft that it can be cut down into pieces. Means it can be cut down with the help of the knife. So, these are soft metals which can be cut easily with the help of knife. With the help of a knife. So most metals, they are generally hard. Exception is there, student, that is sodium and potassium. What about the non-metals? Non-metals, they are quite soft. Okay, so they are not as hard as metals. So, if we talk about non-metals, if we talk about non-metals, non-metals are generally soft, student. Again, is there any exception is there with the help of which we can say that non-metals are hard also? Yes, that is diamond. Diamond. Diamond is what? It is a form of carbon. Diamond is a form of carbon which is the hardest substance. Carbon is what, student? It is non-metal. Carbon is a non-metal. Okay, so diamond, it is a form of a carbon which is a non-metal, and diamond is the hardest substance. It is the hardest substance known. Hardest natural substance, it is a diamond. And diamond is what, student? It is a non-metal. So by this property we came to know the hardness of that of the metal and non-metal. All metals are generally hard except that of the sodium and potassium. Sodium is what, student? It is generally soft, and it is this much soft that we can cut it with the help of a knife. The same thing with that of the potassium. Case of a non-metal, here generally the non-metals are soft, and example is a diamond. Diamond, it is a form of a carbon, and it is known as the hardest substance. Okay, so it is the hardest substance. Okay, it is known as the hardest substance. Moving on, and we will see the next property of the metals and non-metals. Metals and non-metals, students. So let us see, that is the next property, which is thermal and electrical conductivity. Thermal and electrical conductivity. So here generally you will find that metals, they are good conductor of heat and electricity. On the basis of that, we can say that yes, they show the conductivity, that is electrical and thermal conductivity. As compared to that of student in a non-metal, non-metals are generally poor conductor of heat and electricity. Again, here also an exception is there, and that exception is of graphite. You know that graphite is basically used in the batteries. So we can say that a carbon is what? It is quite a good conductor of heat and electricity. So let us write it that metals are good conductor. Good conductors of heat and electricity. Metals are a good conductor of heat and electricity. What does that mean? It means they allow the heat and the electric current to pass through them. Okay, so they allow heat and electric current to pass through them. Okay, so they allow heat and electric current to pass through them. Let us say, student, that which is supposed to be the best conductor of heat. So we can write it here: silver and gold is the best conductor of heat and electricity. Of heat. They are very good conductor of heat. While if we talk about that of the electric current, so they are a very good conductor of heat. Let us find out that which metal is a best conductor of electricity. So silver and gold is the best conductor of a heat, while silver and copper is the best conductor of electricity. So let us write it here, that is, which is the best conductor of electricity. So we can write it here, that is silver and copper is the best conductor of electricity. So silver and gold is the best conductor of heat, and silver and copper is the best conductor of electricity. Okay, so this is how we can say that the metals are the very good conductor of heat and electricity, students. Okay, is any exception is there, student? Yes, lead is a exception in which we can say that. Okay, so this is the exception, student. If we talk about yes, lead is an exception. Lead is a metal which is a poor conductor of electricity. So although all metals are generally good conductor of heat and electricity, but there is an exception, that is lead. Lead is a poor conductor of heat and so this is about the metals, that how the metals are showing the thermal conductivity, student, how they are supposed to be the very good conductor of heat and electricity, as well as they are as well as an exception which says that one of the metal is a poor conductor too. Moving on, and we will see that what about in case of the non-metals. Non-metals, whether they are the good conductor or not. So we can write it here, that is non-metals. So basically non-metals are poor conductor of heat and electricity. Okay, so non-metals are poor conductor of, okay, so non-metals are generally poor conductor of heat and electricity. Poor conductor of heat and electricity. Okay, so non-metals are generally, they are the poor conductor of heat and electricity. What does that mean? It means we do not allow the heat and electricity to pass through it. So comparatively to that of the metals, they are the poor conductor of heat and electricity. Is any exception is there, students? Yes. Diamond and graphite. In case of a diamond, students, you will find that they are a good conductor of heat. So diamond is a good conductor of heat. Good conductor of heat. What about the graphite, students? So I told you that graphite is what? Graphite is a poor conductor of heat. Sorry, it is a poor conductor of electricity. Poor conductor of electricity. Poor conductor of electricity. So diamond is a good conductor of heat and graphite is a poor conductor of electricity. This is how we can say that the metal and non-metals varies with each other is at this property. It means the non-metals, they are generally poor conductor of heat and electricity, and exception is that is diamond, which is not a poor conductor but which is a good conductor of heat and electricity, while the graphite, student, it is a poor conductor of heat and it is a poor conductor of that of the electricity. Sorry, here graphite will be the very good conductor. You have seen in the batteries, students, that is made up of a carbon rod. The material which is present inside it is a graphite. So obviously it is used as a good conductor of electricity. That is why we can say that they are the exceptions in case of the metals, students. Moving on, and we will see the next property of the metal and non-metal, and that is sonority. So, we can write it here, that is sonority. How can you say that a metal is a sonorous or a non-sonorous? Meaning of the sonority. Meaning of the sonorous is what, students? That produces sound. It means when you beat an object, if it is producing sound, then it is sonorous. If it is not producing sound, then it is non-sonorous. So we can say here that it is the property of a substance to produce ringing sound, when struck with a hard substance. When struck with a hard substance. So basically sonority is what? Property of a substance with the help of which it produces ringing sound, and this sound, it occurs when it will be struck with that of a hard substance, students. Okay, so on the basis of that, this property, it will be shown by the metals. Why? You see that metals are generally used for making bell. They are used for making musical instrument. Why is it so? It is because when we struck it, when we beat it, it produces sound. So on the basis of that, we can say that metals are sonorous. Metals are sonorous and ringing sound, and produces ringing sound when hit by a hard substance. When it is hit by a hard substance. Non-metals. Non-metals are non-sonorous and do not produces ringing sound. Do not produces ringing sound when hit by a hard substance. When it is hit by a hard substance. So, sonority is what? It means in which the substance used to produce ringing sound when it is hit with a hard substance. Here, the non-metals, they are non-sonorous. They do not produce sound when heated, and while that of the metals, they are generally sonorous because they produce ringing sound when it is hit with that of the hard substance. So this is how, students, we can see that metals show the property of a sonority, that is sonorous. Next property is, student, that is melting point and boiling point. That is melting melting point and boiling point. Melting point is what, student? It is that particular temperature at which when we burn substance, it starts melting. It means it starts getting converted into that of the solid to liquid. And boiling point is what? In which when we provide heat to it, it starts boiling. It means it will get converted from liquid to gas. Melting is a property in which substance, when provided heat, it starts melting. That is converted to solid to liquid. Boiling point is the temperature at which the substance starts boiling. That is liquid to gas. From liquid to gas. This is what? This is the boiling temperature. So this is the definition of the melting and a boiling point.